Math class is hard to teach. I've taught math at a variety of levels. Now, not K through 12. Most of my, or not normal K through 12. Most of my students have been adults, actually, or you could say putative adults, because they were college students. I have taught gifted students at math camp and Duke University's TIP program. I've also taught adult students who were trying to get GED certification. So they didn't have a high school diploma, and they basically had to do what I would call fifth grade math. They had to learn how to deal with percentages and had a hell of a time with that. But most of my teaching was in the college setting. I taught at North Carolina State University. Yes, I was an undergraduate there. They had a special program for those of us in the honors program, and also they had a screening program to make sure people who were inappropriate to be in front of the classroom so they grade papers instead of really munching up the classroom. um, Taught at NYU. I taught at some junior colleges in New York City as well as Kaplan GRE Prep. And I also did some tutoring of various graduate students in non-math areas. I tried undergrad tutoring for a little bit and stopped it for a variety of reasons. Later, I taught at University of Connecticut, but it wasn't really math classes. It was more business communication, business writing, I would call it. It officially was called technical writing, and then I also did a computing class for the actuarial science students. So those aren't really your standard math classes. But I've taught pre-calculus, college algebra, as I said, GED, level math, calculus, your standard courses. I want to focus on the standard courses and not so much the courses for the gifted students, because the easiest classes to teach for someone who knows math are the most advanced math, because all of the students you have can self-teach, at least at that level. That is just the truth, and that's how that works. But the most challenging classes to teach are the sole math class, a non-STEM major, okay, that's science, technology, engineering, and math, has to take in college in order to get their degree. Because of the way we have college degrees, you have to have a general education requirement. And I'm sorry to say, generally what is required to get a degree in the US is at best high school level mathematics to get a degree. I wouldn't call it college mathematics, really. We can argue whether or not this should be required another time, especially since the humanities and social science requirements for the STEM majors are at a much higher level. Again, that is for another time. The problem, of course, if you're teaching one of these college math classes to people who almost definitely hate the subject, and the reason they hate the subject is the same reason it's so difficult to teach math at any level beyond the basic level. So I would say beyond elementary school level. And that is because math is additive. And if you have a crucial hole early on, it's unlikely that hole will get filled because they have to keep pushing on. And then you don't understand the math the farther you go. The biggest problems I had in teaching even the calculus class that was intended for engineering majors at NCSU was a lot of them had sketchy understanding of algebra, first year algebra, and geometry. I remember one of the biggest arguments we had to do with whether it was reasonable for me to expect the students to know the equation or the formula for the area of a circle. You would think calculus students would know that, pi r squared, and it's one of my dad's corniest jokes he used to tell me, where the punchline was, pi aren't square, cornbread are square, pi are round. Yeah, it's corny, as I said, literally. But that's an issue. And it's very tough at the college level to repair all of the damage that had been done earlier. We generally do not have enough time to do one-on-one with the students. Thank goodness I have resources to give adult students now, but you have to take responsibility for your own education. Khan Academy, Khan Academy, has just lots of stuff for any math learner at any level. Okay, maybe not elementary school, but high school level and higher. Even if you have a very basic math whole, like say long division, it's there. And there are practice problems, and you can do them over and over. The great thing about Khan Academy is it has a whole kind of web of how the topics interrelate. And again, the issue is a lot of people start falling behind in elementary school. And I think the place where they really start falling behind is division, because that's the first one that's complicated, especially if you have to do long division. But even if you're given a calculator, division is difficult to understand once you start getting into fractions, especially if you're having to deal with fractions with different denominators and percentages. It's generally not intuitive to most people. People can understand intuitively adding numbers and even subtracting numbers. After, a little bit, you can draw some sketches and that kind of thing. Multiplication starts to become a little understandable. But division, I think, is that first conceptual leap. It's well before algebra that the problem starts. Algebra has a certain level of abstraction that starts to be a problem, especially if it is introduced to the student too early. And this is true for a lot of abstract concepts in math. I mentioned I've dealt with gifted students in math. And yeah, they can be gifted. They can very high IQ, very well educated, but a topic such as infinity it's maybe too soon for them to be introduced to them. I had tried to do Cantor's diagonal argument with a set of Duke Tip students, and I don't think any of them got it. And to math people, this is a fairly simple proof, but I think most of us who are math people who have dealt with that there are different kinds of infinity and that we have folded it into our minds, I don't think most of us remember how difficult a concept that is. You need to think about how it took until the 19th century that there may be different infinities, that the mathematical community understood it. So the more recently a concept was developed, most likely that's going to be very difficult for most people to understand in any kind of way. And generally, if it's really recent, it's actually not that important for you don't need to know about Aleph null and Aleph 1 and C and all of that. Most people don't. Even if you're a mathematician, most fields of mathematics, you don't really need to know that. It depends on what you're working in. Anyway, getting back to regular math that most people need to learn and pass. The issue is the way our schooling is set up with institutional schooling. It's in chunks and units, and you have to do it as a group. The problem is, of course, not everyone is going to have the same course, and even if you were all in the classes together, someone could get sick, something happens, or there might be just one thing they get stuck on, but the teacher doesn't have time to go back and just treat with that one student. And it's cumulative. And most parents and definitely most students don't know how to go back and fill those holes. So it becomes difficult. I have a lot of sympathy for those who are trying to get students up to standard and find that the hole is 5 years back. It is a bit of an ego blow to the student to tell them this. This does not mean you're stupid, but other subjects like science, history definitely, and reading and literature, There are entire authors I have not read that are part of the great canon, and I am not hurting for not having read it. There are some major ones, like if you haven't read Dickens, you're fine. In English literature, you need to have a little bit of Shakespeare, but you don't need to have seen all of Shakespeare's plays. You don't need to have read any of Chaucer, and you can do just fine in literature. In history, oh, there's whole swaths of history, even European history. I don't know. It took me, it wasn't until after graduate school that I finally got it. When the Romans were in England and were the Vikings, it doesn't matter. It doesn't matter for most of my understanding of history that I didn't know that. Okay. However, if you don't understand how to add fractions or what fractions mean, that is going to impinge on your ability to do the equation of a line in algebra. It's going to impinge on understanding related rates in calculus. You probably won't, if you don't understand fractions too well, you probably won't get to calculus. But I have seen many students being able to just get by in a subject and get promoted to the next one, having gaping holes in their math understanding. And they're really not learning the additional math. What they're learning is a recipe book. And if the problems they're given are in an exact algorithmic order that, oh, first I do step 1 and then 2 and 3, and it's just mechanistic to them, they may as well have a computer do it for them because they are just following what they see as a series of steps and there is no understanding. And this is just the reality of what people put up with. I had students, they just needed to get a D in the class to pass. And this is college algebra, this is pre-calculus, this was probability and statistics. These were the kinds of classes I had to teach this was the only class they were going to be taking in college, and they needed it to graduate. The saddest ones, of course, were the ones who waited until senior year to do this. Okay, this is a serious piece of advice. If you have a subject that you hate, that you are required to have a certain course distribution, whether it's 1 or 2 semesters, in order to graduate for your degree, get it done your freshman year or sophomore year at the latest. Because once you get to the senior year and you get desperate, I got to tell you, it's not your professor's problem that you're not passing. It's your problem. And the professor is really not going to have a lot of sympathy that you put off until senior year a subject you knew you were going to have difficulty with. Because if you fail freshman year, then you can try again. Okay? You have to take responsibility for your education once you're an adult. You should take responsibility before that, but you are really expected once you're an adult. Maybe people are not telling you that. I am telling you that. In any case, back to sympathy for the math teachers. This is the truth. You have someone trying to teach calculus, and then they throw a bunch of students who are ill-prepared for the subject. In ye olden times, the professors would just fail you. Again, it's not our problem. But there are some, I mean, and a lot of times it's adjuncts, we would like you to know the subject. And it does not help to say, oh yes, you're passing, when you don't actually know the material. I don't know what to tell policymakers. The problem is math is cumulative. What you may want to look into are math boot camps. And another thing, I just want to tell you, you can't make math fun. And I don't want to make this depressing. I find math fun, and there's a lot of fun math out there, but you actually have to go in there and do the work. This is like, say, athletics, doing wind sprints and that kind of thing. Some students find that, or some athletes, I should say, find that fun. Practicing scales in music, other kinds of prep work. You have to do the work. You have to put the work in. You shouldn't make students feel guilty that they don't find something interesting, that they find something boring or difficult. Fine, work with that. just say, yes, I understand it is difficult. You have to do the work. We are here to help you to get through this work. It's got to get done. Yes, there are going to be some students who are intellectually disabled, like, say, my son, who's autistic. He's not able to get past a certain level. Okay, he took the state achievement or whatever they call it here in New York, the grade level exams, and he was below 10th percentile. I know that. It's single digit. I didn't really see the point of him taking the exams, but I guess someone has to be single percentile. Um, but he's not going to be taking calculus, not where he is now. Maybe one day, but I'm thinking it's unlikely. Most students, though, are going to be able to at least do arithmetic, basic geometry, first level of algebra. Okay, maybe not up to quadratic formula, but at least the equation for a line and maybe where two lines intersect. Everyone should be learning percentages and interest rates and that sort of thing, consumer finance. I think every student will be able to achieve that, except for those who are intellectually challenged, and that should not be a huge percentage of the population. I know it's not fun. It's much more fun telling stories about ye olden days and various ancestral peoples that did this, that, and the other with math. And it's just fine to have role models, such as the women who worked on the NASA and doing the computations, numerical integrations and stuff for orbital mechanics. And you can get into that, though most of the K through 12 teachers are not going to understand or know the math that goes into that, just to say this is what you can achieve. But they actually have to sit down and do the math. Telling stories about math is not the same as doing the math. You got to do the math. And I know it's not fun for most students or for most teachers, but it's got to be done. Just like you got to learn to read and you got to learn to write. So just do it.